Solving quadratics by square roots. It turns out that we can solve quadratics quickly if we have a square that we can get by itself. If I look at a question like x squared equals 9, be aware that there are two numbers squared that make 9, because 3 squared, that's 3 times 3, is 9, and negative 3 squared, which is negative 3 times negative 3, is also positive 9. When we solve with the square root, we take the question x squared equals 9, and we take the square root of both sides. But we understand that there are two numbers squared that make 9. One was negative 3, and one was positive 3. To make sure I get both answers, what I do is opposite the square, I put a plus or a minus. The square root of 9 is 3, and I say the answer, x, is plus or minus 3. What this means is that there are two answers. One is positive 3, and the other is negative 3. We're writing both answers as one nice short answer. To solve x squared equals 25, then, I take the square root of both sides. We understand there are two answers. To get those, we put a plus or a minus. And our answers are plus or minus 5. Square root of 25 is 5. Again, this is two answers. One is positive 5, and the other is negative 5. We're writing both those answers as a single answer, plus or minus 5. Be aware this solving by square roots does not work well if you have something like x squared plus 3x equals 25. The problem here is I'm not able to take the square root of this square because of the 3x. I'm not able to get the x squared by itself and take the square root of both sides. So if there's a middle term like this quick solving doesn't work as well. It turns out there's a way to make this a square called completing the square, and we'll talk about that soon. Here are some quick examples. In order to take the square root of both sides and take the square root of a square, I need to move the 9 to the other side. Take a 9 off each side. I get x squared equals 3. Now I can take the square root of both sides, and I understand that there are two numbers squared that make 3. So I put a plus or a minus, and my answer then for x is plus or minus. There is no square root of 3 that's a nice answer, so we'll just leave that as the square root of 3. X squared minus 7 equals 11. Let's get this square by itself, so we can take the square root of each side. We'll put a plus 7 on each side. I get x squared equals 18. I can take the square root of both sides, and I'll put that plus or minus in front to get both answers. Be aware that 18 is 9 times 2. The square root of 9 is 3. That'll go out in front of the root. Don't put it out in front of the plus or minus. That would be completely different. The plus or minus is the sign of our answer. One is positive, one is negative. The square root of 9 is 3. Left underneath the root is still this 2 that I couldn't take the square root of. The answer then is plus or minus 3 root 2. This next one, I'm going to take a 5 off each side, and I get 2x squared equals 12. I'm going to get the square by itself. I'll divide both sides by 2, and I get x squared equals 6. I'll take the square root of both sides and put my plus or minus, and I get x equals plus or minus the square root of 6. For the last one here, I'm going to add 7 to both sides, and I get 3x squared equals 11. I'll divide by 3, and I get x squared equals 11 thirds. I'll take the square root of both sides and put a plus or minus in front. Now, be aware that 11 thirds is the square root of 11 over the square root of 3. Don't forget the sign plus or minus. We need to rationalize that because we don't leave a square root in the denominator. We multiply the top and the bottom, the numerator and denominator, by the square root of 3. And I get x equals, plus or minus, don't forget the sign, root 11 times root 3 is root 33. The square root of 3 times the square root of 3 is the square root of 9, and the square root of 9 ends up being 3. My answer then is the square root of 33 over 3. It turns out you can solve a variety of equations this way, even ones like this, because I can eliminate the square by taking the square root of both sides. I need that plus or minus to get both answers. The square and the square root are inverses of each other. They eliminate each other. I'm left with x plus 1 equals plus or minus the square root of 16 is 4. I can get x by itself by taking a 1 off each side. Now, this is a little strange here. Typically what we do, though, is we put that 1 in front. And we say our answer is x equal negative 1 plus or minus 4. There are times that we're done at this point because we might end up with the square root of a number here like 5 or 7. And I can't combine negative 1 and the square root of 7 or negative 1 and the square root of 5. I can't add them or subtract them. But the square root of 16 was for a whole number or an integer. I can subtract negative 1 and 4 and I can add negative 1 and 4. So I can keep going. I can simplify this answer. My answers will be x will equal negative 1 plus 4, and x will equal negative 1 minus 4. Negative 1 plus 4 and negative 1 minus 4. Simplify those two answers. You get 3, there's 1, and negative 5. Be aware that you can check and see if these answers work. If I plug in 3 in the original question, notice how 3 plus 1 is 4 and 4 squared is 16. If I plug in negative 5 in the original question, negative 1 plus 5 is negative 4, and negative 4 squared is positive 16. I can see that these answers work, 3 and 5. The process then is, when I have a square, take the square root of both sides. To get two answers, put a plus or a minus. Here I would have x plus 3 equals plus or minus the square root of 5. Take a 3 off each side. We put this 3 in front, typically. X will equal negative 3 plus or minus the square root of 5. This is two answers. One is negative 3 plus the square root of 5, and the other is negative 3 minus the square root of 5. When you enter these in WAMAP, it may ask you to enter both answers, and you'll have to enter them like that. Notice I couldn't go any farther in this case because I can't add negative 3 and the square root of 5, and I can't subtract negative 3 and the square root of 5 because they're not like terms. Take a look at the next example. I'll take the square root of both sides to eliminate the square, put a plus or minus. X minus 4 equals plus or minus the square root of 20. The square root of 20 is 4 times 5. That can be simplified. The square root of 4 is 2, so this is plus or minus 2 root 5. I'll add 4 to both sides, and we'll pop that 4 in front. X will equal 4 plus or minus 2 root 5. I can't do anything else with this because I can't add 4 and 2 root 5, and I can't take 2 root 5 from 4. There are two answers here. One is 4 plus the 2 root of 5, and the other is 4 minus 2 root 5. For this last one, I'll take the square root of both sides and put a plus or minus to get both answers. 2x minus 7 equals plus or minus the square root of 75. 75 is 25 times 3. I get 2x minus 7 equals plus or minus the square root of 25 is 5, 5 root 3. I'll add 7 to both sides, and I'll pop that in front. 2x will equal 7 plus or minus 5 root 3. This one's a little bit weird here, but what I'm going to do to get x by itself is divide by 2. And this is not a friendly answer, but this is actually your answer. Keep in mind again, this is two answers. One is 7 plus 5 root 3 divided by 2, and the other answer is 7 minus 5 root 3 all divided by 2. The rest of this video is questions from your assignment. Question 1. Let's solve x squared equals 81. Take the square root of both sides, opposite the square, put that plus or minus. The answer then is x equals plus or minus 9. This is two answers. One is positive 9, the other is negative 9. And this is what we enter into WAMAP. List them separated by a comma. Be aware, this is not an ordered pair. Do not put parentheses around it. If you do that, it's an x and a y. This is actually an x and an x, not an ordered pair. Question 3, x squared minus 5 equals 44. Get that x squared by itself. Add a 5 to both sides. X squared equals 49. Square root both sides and put that plus or minus to get both answers. X equals plus or minus 7. The square root of 49 is 7. This is two answers, positive 7 and negative 7. Question 4. X squared equals 242. Take the square root of both sides, put a plus or minus in front. Now 242 may have perfect squares in it. This root may be simplified. We're always going to put it in simplest radical form. Maybe it's divisible by 4. I'll take 242. I divided it by 4 and I got 60.5. So this does not have a perfect square of 4 in it. The thing I notice is that it's even. So rather than look for a perfect square, let's just divide it by 2 to see what's left. Maybe it'll be a perfect square. Maybe we can find the perfect square in that number. If we divide that by 2, we get 121. And look at that. 121 times 2. The square root of 121 is 11. I'm going to put that in front. Be aware that this plus or minus is the sign of the number. It goes in front of your number, just like a negative would. Square root of 121 is 11. Left underneath the root is a 2. Plus or minus 11 root 2. In WAMAP, you're going to need to list this as two separate answers. One of them is positive 11 root 2, and the other is negative 11 root 2. Question 5. X squared equals 75. Put a plus or minus in front of that thing. Square root both sides. This is 25 times 3. Plus or minus goes in front. It's the sign of the number. Square root of 25 is 5. That goes in front of the root. 5 root 3 is my answer, plus or minus. In WAMAP, you're going to need to list that as two answers, 5 root 3 and negative 5 root 3. Question 8. 49 x squared equals 25. To get the square by itself, I'll divide each side by 49. X squared equals 25 over 49. I can take the square root of both sides to get rid of that square. I'll put a plus or minus in front. I get plus or minus. The square root of 25 is 5, and the square root of 49 is 7. Plus or minus 5/7. Remember, this will be written as two answers in WAMAP. One will be positive 5/7, the other will be negative 5/7. Question 9. X squared minus 16 equals 304. Let's get the square by itself and add 16 to both sides. X squared equals 320. Square root both sides and put your plus or minus opposite the square. I know this is divisible by 16. Let's try that. 320 divided by 16. The reason I knew that is because 32 is divisible by 16. I notice that this is 16 times 20. 20 still has a perfect square in it. It is 4 times 5. 4 is that perfect square. There's a 4 in the 20. There's a 16 in the 320. And both of these make a larger perfect square. 4 times 16 is 64. The largest perfect square is 4 times 16, 64. X equals plus or minus, I'm going to rewrite this as 64 times 320 divided by 64 is 5. This is plus or minus. The square root of 64 is 8. 8 root 5. This is two answers. Positive 8 root 5 and negative 8 root 5. Question 10. X squared minus 22 equals 338. Add 22 to both sides. 338 plus 22 is 360. Square root both sides and put your plus or minus in front. This is 36 times 10. Square root of 36 is 6. That goes in front of the root. 6 root 10 is the answer, plus or minus. Write that as two answers, 6 root 10 and negative 6 root 10. Question 11. X squared plus 3 equals 56. Take a 3 off each side. X squared equals 53. Square root both sides. Put a plus or minus in front. X equals plus or minus square root of 53. 53 is not divisible by 4 or 9. I'm just looking for a number that divides into 53 even. It's not divisible by 2 or 3, because if you sum the digits, you get 8, and 3 doesn't divide into 8. That works for 3 and 9, remember. 4, because it would have to be divisible by 2. It doesn't divide by 4. Or 5, it'd have to end in a 0 or a 5. Or 6, because 2 or 3 don't go in. 7 doesn't go in. 7 times 8 is 56. 7 times 7 is 49. Doesn't look like there's anything that divides into 53. It's a prime number. The answers then are positive square root of 53 and negative square root of 53. Question 12. X squared plus 10 equals 70. We'll get that square by itself. Take a 10 off each side. X squared equals 60. Now to get x, we'll take the square root of both sides and put that plus or minus there. There's a perfect square in 60. It would be 4. 4 times 15. I can take the square root of 4 that goes out in front of the root. Make sure you put the plus or minus first, though. That's the sign of the number. It always goes in front of the number. Square root of 4 is 2. In front of the root. Left underneath the root is 15. Plus or minus 2 root 15. In YMAP, we'll write that as 2 root 15 and negative 2 root 15. Question 13. 36x squared minus 9 equals 0. I will point out that you could factor this to solve it. It's a difference of squares. It would factor. But because there's no middle term, there's no 6x or 2x, anything like that, we can just solve for the square. Move the 9 to the other side. Add 9. 36x squared equals 9. Divide by 36 to get the square by itself. X squared equals 9 over 36. This would reduce if you want, but you can also just take the square root of both sides, because the square root of 9 will be 3. Don't forget your plus or minus. And the square root of 36 will be 6. Now you have to be aware that 3 over 6 is a half. So this becomes x equals plus or minus 1/2. We'll write that in WAMAP as 1/2 and negative 1/2. If you'd made this x squared equals 9 over 36 and reduced it right off, notice those are both divisible by 9, you get 1/4. Notice that when you take the square root of both sides, you get the same thing. Plus or minus the square root of 1 is 1, and the square root of 4 is 2. Plus or minus 1/2. Question 16. Let's solve for the square. We'll add 28 to both sides. This is negative 2x squared equals negative 972. Divide both sides by negative 2. We get x squared equals 486. Take the square root of both sides. Put your plus or minus in front. We're looking for perfect squares in 486. I divided it by 4 on a calculator. That did not work. I noticed the digits when I sum them. 4 plus 8 plus 6 is 18. 9 goes into 18. Remember, this works for 3 and 9. If 9 or 3 divide the sum, then 9 and 3 go in evenly. Since 9 goes into 18, 9 will divide evenly into 486. I divide that by 9, I get 54. Now I notice that 54 still has a 9 in it because it's 9 times 6. That's 54. And these two 9s are going to make a perfect square of 81. 81 divides into 486. I divided 486 by 81. I got 81 times 6. The square root of 81 is 9. That goes in front of the root. Plus or minus 9. Left underneath the root is still a 6. Plus or minus 9 root 6. We'll write that as two answers. Positive 9 root 6 and negative 9 root 6. Question 18. 2r plus 4 squared equals 16. To get rid of that square, take the square root of both sides, put a plus or minus on the other side. This becomes plus or minus 4. The square and the square root are inverses of each other. They eliminate each other. We get 2r plus 4 equals plus or minus 4. Take a 4 off each side. We put that 4 in front. You got 2r equals negative 4 plus or minus 4. Get the r by itself. Since there's times right there, we're going to divide both sides by 2. And r will equal negative 4 plus or minus 4 divided by 2. At this point, often you are done. If this had ended up being a square root, like the square root of 5 or the square root of 7, we couldn't go any further because we couldn't combine any of these terms. However, here, they're all integers, just regular old numbers, and we can simplify. There are two answers. One is negative 4 plus 4 divided by 2. The other is negative 4 minus 4 divided by 2. First one becomes 0 divided by 2, which is 0. The second one becomes negative 8 divided by 2, which is negative 4. Our two answers then are 0 and negative 4. Question 19. 2x minus 9 quantity squared equals 0. Take the square root of both sides, put a plus or minus over here. Notice that the square root of 0 is 0, and 0 plus or minus 0 is still 0. I get 2x minus 9 equals 0. We'll add 9 to both sides. 2x will equal 9, and divide by 2, and x is 9/2. Depending on the question, you could also make this 4.5. It depends on whether the answer is expected to be a fraction or a decimal, but 9/2 is the same thing as 4.5. This is the correct answer. Question 20. X minus 2 quantity squared equals 9. We'll square root both sides and put our plus or minus in front. Square root of 9 is 3. We get plus or minus 3. X minus 2 equals plus or minus 3. Add 2 to both sides and pop that in front. X equals 2 plus or minus 3. These can be simplified. They're both integers, regular old numbers. We get two answers. One is 2 plus 3, and the other is 2 minus 3. X equal 5 and x equal -1. 5 and -1 are our solutions. Question 21. X minus 4 squared equals 36. Let's take the square root of both sides and put a plus or minus there. X minus 4 equals plus or minus 6. Square root of 36 is 6. Add 4 to both sides and pop that 4 in front. X equals 4 plus or minus 6. Since these are both regular old numbers, we can simplify. We get two answers. One is 4 plus 6. That's 10. The other is 4 minus 6. That's -2. 10 and -2 are the answers. Question 22. R plus 2 quantity squared equals 32. Square root both sides, put a plus or minus over there. R plus 2 equals 32 is 16 times 2. There's a perfect square in 32. In front of the root, we'll have the square root of 16. That's 4. Left under the root, we'll have a 2. Get the R by itself, take a 2 off each side, and we'll pop that 2 in front. And our two answers are in the form of -2 plus or minus 4 root 2. I cannot combine these. They are not like terms, but I can split them up into two answers, -2 plus 4 root 2 and -2 minus 4 root 2. Question 23. X plus 10 quantity squared equals 22. Let's square root both sides and put our plus or minus over there. You get x plus 10 equals plus or minus root 22. The square root of 22 cannot be simplified. It's 2 times 11. There are no perfect squares in there. We'll take a 10 off each side and pop that in front of the plus or minus. X equals -10 plus or minus root 22. This cannot be simplified. There are no like terms there. We'll write it as two answers, -10 plus the square root of 22 and -10 minus the square root of 22. Question 24. J plus 3 quantity squared is equal to 39. Square root both sides, put a plus or minus in front. 39 is 3 times 13. No perfect squares there. You get J plus 3 equals plus or minus the square root of 39. We'll take a 3 off each side and pop that 3 in front. J equals -3 plus or minus the square root of 39. These are not like terms. I can't combine that or simplify that. Let's write that as two answers. Negative 3 plus the square root of 39 and negative 3 minus the square root of 39. Question 25. X minus 8. Quantity squared equals 13. Square root both sides. Put your plus or minus in front. X minus 8 equals plus or minus the square root of 13. 13 is a prime number. There are no perfect squares in 13. Let's add 8 to both sides and put the 8 in front of the plus or minus. X equals 8 plus or minus the square root of 13. Write that as two answers, 8 plus root 13 and 8 minus root 13.